So as you might guess, with a title this long, this talk has multiple parts. In part one, I'm going to present some work led by Florencia Pereira and Bruce Walker, showing that the protective effect of HLA class I alleles on viral load is mediated by CTL responses to specific epitopes. And then in part two, we'll use these results to find a hidden success in the STEP trial. Namely, we'll see that vaccine-induced targeting of these specific epitopes is associated with lower set point viral loads in those participants in the STEP trial who became infected. So there are numerous studies showing that HIV-1 elicits HLA class I restricted CTL responses to multiple different epitopes, and that certain HLA class I alleles are associated with control of HIV, whereas other HLA class I alleles are associated with progression to AIDS. However, some individuals who have these protective alleles have high viral loads. Now, one possible explanation for that is that it's not the HLA alleles that are responsible for viral control. Rather, it's the specific CTL epitopes targeted by an individual that are responsible for viral control. So to look at this question, we identified a set of individuals, some of them who controlled the virus, some of them who didn't. We measured their HLA alleles, measured their specific epitopes targeted, and then asked the question, which sets of these features best predict viral control? Do HLA alleles alone best predict viral control? Do the specific epitopes targeted by the individual best predict viral control? Or do we need both sets of these features to best predict viral control? And as you'll see, the answer to these questions will help us look at this hypothesis. So we recruited individuals from throughout the United States. We found 148 viremic controllers. These are not elite controllers. This is not as stringent a criterion as that. And we also found 102 chronic progressors. We typed their HLAs. We assessed their responses to known optimal HIV epitopes using ELISpot assays. And the list of these known optimal epitopes came from et al. And there's one caveat here, which is all epitope individual pairs with a compatible HLA were tested. That is, if an epitope had a known HLA restriction and the individual had that HLA, then we tested that pair for a response. However, only samples of incompatible pairs were tested. We tested several hundreds of pairs, found essentially no responses, and for purposes of the analysis that I'm about to show you, we assumed that these incompatible epitope individual pairs would not show a response. So as I mentioned, we took this data and then we built predictive models predicting whether an individual was a viremic controller or a chronic progressor. We did this with logistic regression, and we evaluated these predictive models with ROC curves. Now, you don't need a deep understanding of ROC curves to understand these results. So basically, an ROC curve is a plot of false negative rate versus false positive rate. If you have a predictor that does no better than random, you get the ROC curve shown here, a diagonal. If you have a predictive model that does better than random, you get an ROC curve in this upper left-hand part of the graph. And the closer the ROC curve is to the upper left-hand point in this graph, the better are the predictions of your model. So let's look at the results. Now, if you just use the HLA information about an individual to predict whether or not they're a viremic controller or a chronic progressor, you do better than random, and significantly so. If instead you use only the epitope responses to predict whether an individual is a viremic controller or a chronic progressor, not only do you do better than random, but you do better than the HLA alone model, significantly so. And finally, if you use both the HLA information and the epitope information to predict viral control, you don't do any better than if you just use the epitope responses alone. So to summarize that, epitope responses best predict viral control, and HLA provides no additional information. These two things in combination suggest that the HLA class I control of HIV is mediated by the targeting of these CTL epitopes. Now with that, obviously you want to know which epitopes are leading to viral control. And to answer that question, we went back to logistic regression to predict viral control from epitope responses. But now, instead of using all the epitope responses at once to predict viral control, we looked at responses to specific epitopes one at a time, adding them to our model one at a time to see which ones were significant. And using a false discovery rate cutoff of 20%, we found these 6 epitopes are significantly associated with viral control. Now, for lack of a better name, we call these good epitopes. Perhaps protective epitopes is another possible name. And for those of you that saw Steve Deek's talk last night, I promise you we won't call them elite epitopes. What's interesting is that half these epitopes are not in GAG. There's 1 in BPR, 2 in NEF. And also interesting is that the restrictions of 2 of these epitopes do not correspond to HLAs that were previously thought to be protective. We have the B14 DA9 epitope and the AO2 LV10 epitope. There we go. So now, with this list, then, we want to look at the STEP trial, where despite induction of CTL responses, administration of the vaccine failed to reduce viral load in participants who acquired infection. So we thought, well, could the lack of targeting of these good epitopes be responsible, at least in part, for this? And in particular, we wanted to look at the question, do participants in the STEP trial who target these good epitopes after they're vaccinated but before they become infected, do these individuals have lower set point viral loads after they become infected? To look at that, we performed ELISpot assays on 19 vaccinees, in particular on 19 post-vaccination pre-infection samples. And rather than look at optimal epitopes here, we looked at mini pools spanning GAG, POL, and NEF. A mini pool consists of 5 overlapping 15-mers spanning 31 amino acids. If we saw a response to this mini pool, we attributed that response to any known optimal epitope within the mini pool, such that those epitopes had the HLA restrictions consistent with the HLAs of the individual. We then took these predicted responses to optimal epitopes and correlated those with early set point viral load in the individuals. Now, if you just look at the total number of responses to targeted to epitopes, you don't see much of a pattern. On the y-axis here, we have log set point viral load of the individuals after they became infected, and on the x-axis, we have the number of predicted optimal epitopes that an individual responded to after they became infected, but after they were vaccinated, but before they became infected. And as you see here, there's no significant trend. If anything, or significant result. If anything, there's a positive trend such that the more epitopes an individual reacted to after they were vaccinated, the higher their viral load after they became infected. But now, let's look at the good epitopes. Now you see a very striking pattern. No individual in the study reacted to more than 1 good epitope. So there's only 2 possibilities. They either reacted to no good epitopes or 1 good epitope after they were vaccinated, but before they became infected. And with one exception, this individual here, all those individuals who reacted to a good epitope after they were vaccinated, but before they became infected, had lower viral loads after they became infected than those individuals who did not react to a good epitope. Now, there's only 19 individuals in this study, but because of this very striking pattern, you still get a very significant result. It's also interesting to look at those individuals who could have only responded to this AO2 restricted LV10 epitope in NEF. These are individuals who have AO2, but they don't have other alleles that might allow them to respond to a different good epitope. There are 10 such individuals. 4 of them responded to LV10, 6 of them did not, and without exception, those individuals who responded to LV10 had lower viral loads after they became infected than those individuals who did not respond to LV10. Now, we did a couple of sanity checks. We looked at the usual covariates in the STEP study, but we couldn't find any significant correlation either with a response to a good epitope or set point viral load. These are the p-values here. You see there's nothing significant. And finally, just one slide to speculate. and perhaps tell you about some of the possible consequences of this work. We have these, let's focus on these 6 non-responders to LV10. They could have responded to LV10, but they didn't. Well, why? Well, one hope is the reason that they didn't respond is because their immune system was distracted by targeting other epitopes that were available to target in the immunogen. So in fact, indeed, if you look at these 6 individuals, these non-responders to LV10, they did respond to at least, each of them did respond to at least one other epitope. And that brings us to, I think, a key question, which is, if given the chance to target only LV10, so in the extreme, if you were to administer an immunogen that only has LV10 in it, what fraction of AO2 individuals would target LV10 without the distraction of the other possible epitopes to target? So to conclude, both the analyses I showed you suggest that HLA class 1 control of HIV is mediated by the targeting of specific T-cell epitopes, that these good or protective epitopes are limited neither to GAG nor those presented by protective alleles, and perhaps most important, that the design of a successful vaccine immunogen may hinge not only on the inclusion of these good epitopes, but on the exclusion of other epitopes that might distract the immune system from targeting these good epitopes. With that, I'd like to thank my collaborators, especially Florencia Pereira and Bruce Walker at the newly formed Reagan Institute, Danny Casimiro at Merck, Nicole Fromm, Julie McElrath at the Hutch, Jonathan Carlson and Carl Cady at Microsoft Research, and to Philip Goulder and Bruce Walker, who first told me about the possibility of there being these good epitopes. Thank you very much. Questions?
Here, I'm over here. Can I ask a question, please? What, is there diversity in these epitopes, and could it be that the viruses they were infected with have diverse sequences within them? Could there be a T?
We looked at LV, because LV10 was so interesting, we immediately started looking at that one. LV10 happens to be in one of the most conserved regions of NEF. There are a few variants, and in some unpublished work that Nicole Fromm, Christian Brander, and I did, we found that among the very few variants you see with LV10, you see a lot of cross-reactivity with those anyway.
So it's not likely that that's an issue.
Yes.
Questions?
Joey, you're on again, sorry. I may totally not get this, but you find epitopes that are associated with low viral load, and then you show that they're associated with low viral load. It would seem to me the only appropriate control for this are placebo recipients that respond to the same epitope and show that somehow their viral load is lower. It's entirely circular unless I'm... maybe an immunologist could...
Yeah, it's not completely circular in that we found these epitopes associated with low viral load in a set of HIV-infected individuals, and then we took that list and looked at if individuals who were responded to these epitopes after they were vaccinated, but before they became infected, what happened to their viral loads after they became infected. So there is a difference there.
Yeah, I don't see it. I mean, how do you know that if they'd gotten infected, they wouldn't have responded to those same epitopes and without vaccination and had a lower viral load?
Absolutely. We're very interested in getting that data, and it's coming soon. We want to look at what happened to these individuals after they became infected in terms of their CTL responses. That data apparently, at least some of that data will be made available, and we're very interested in looking at that.
I'll ask the question in a slightly different way. What evidence do you have that there's a vaccine effect in those individuals that would make those responses in any case?
We don't. I think it's clear that we want, the study that I would like to do is to provide LV10 as an immunogen without the distraction of other potential immunogens and see what sort of responses you get.
So I would just caution that looking at just the epitopes, especially in the first part, the chronic infection portion of your talk, epitopes and MHC are inextricably linked. for example, for people in the audience that don't do this every day, if you have a KAF response, that individual almost certainly has HLA-B57, right? And so you found a bunch of peptides that are quote-unquote good epitopes, but I would counter that probably that's not really, that's your interpretation, but that's not really how it's mediated. The progressors with very high viral loads have responses to many of those same epitopes, and very big responses, and they might have 200,000 copies. And so the only real control is individuals that control the virus and don't control the virus matched at MHC and differing at the epitope specific responses. With regard to the vaccine portion of what you're saying, the other confounder there potentially is the total response. So I saw that you had with the last response, the LV9,
LV10.
LV10, you had controlled for another response, but what are the total responses of those same individuals? If you measured, was there a difference, in other words, in take? So did the individuals with a lower viral load have a larger response to the vaccine if you added up all of their responses, or was this really confined to LV10?
We did the overall analysis showing that regardless of how many epitopes you responded to, it didn't correlate with your viral load. Did we do that specifically? And then we contrasted that with responding to good epitopes or not. Did we do that for LV10 in particular? No, although LV10 are most of the responders, so I wouldn't expect that sort of result to come up. And regarding your first point, yes, there are some epitopes such that when you see them react, that pretty much determines their HLA, or you know that they have a particular HLA. But there are many epitopes for which that is not true. And for those epitopes, you should see a signal. If there was a direct HLA effect on viral control, you should see that signal come out in our ROC curves, and we didn't see that signal.
Just to follow on that,
We have to, Bonnie, we have to cut right now because we're falling way behind. You can talk with David after the session, I'm sure, and get these questions. I apologize to the questioners, but we just don't.